Alright, so your goal for this lesson is to complete the 3-part video questions. Some of them are a little weird and some of them are pretty easy, so I might set you up to solve the problem and you will have to finish it. After that, you need to see us to see what homeworks you can make up if you missed any, and then you need to practice slope for the next unit. Okay? So in number 1, you have a figure with 2 semicircles with centers P and M. The semicircles are tangent to each other at point B, and say ray DE is tangent to both semicircles at FE. Shout out to Mr. Rankin because he helped us solve this one. So the things we had to remember are, you should write these down, tangent to the radius is 90 degrees. So that helped us establish right triangles. And I will put those in. Okay, so I'll actually use a straight line. No, I won't. Maybe I will. Yeah, so from F to P and from E to M, those are radiuses of a triangle. Radiuses of a circle, which makes a right angle right there. Okay, so I'm going to do one in red, and then I'm going to do one in blue. Okay, so we have 2 radiuses that make a right angle with the tangent. So you're also going to be thinking about right triangles. And for kicks and giggles, they're going to throw us similar triangles too, because the park is so nice and complicated. So hopefully if you think about similar triangles, you start to think about proportions. Okay? And so what I'm going to do is I just put in my radius to my tangent to make a 90-degree angle. I'm going to label my lengths. We have 6, and that's actually a radius. So that means this is also 6. And then, okay, so that's all we know for right now, except for BC is 6, which means its radius is 3, 3, and 3. Okay? So what starts to happen is you start to think about what you need to find, and you need to find the length of ED. Okay, and I'm going to highlight a triangle that's going to be out here. Okay, so we need to find the segment, the length of ED. So I'm going to actually pull a right triangle out, and I'm going to make it E, M to D. Okay, and that's just a right triangle that we had. We know the length from E to M is 3, and we know the length from M to D is 3 plus something that we don't know, so 3 plus X. Okay, and then we also know that I'm going to highlight another right triangle. So from F to P all the way over to D, you can see there's some overlap. Okay, and I'll do this one in blue. So we have F, P, all the way over to D. Okay, and then from F to P it's 6, and now from P over to D it's 6 plus 3 plus 3, which gets you to 12 plus something. So 12 plus X. Okay, so now we are going to use similar triangles. Okay, so we have, if we do 3 to 6, so 3 over 6 is going to equal 3 plus X over 12 plus X. Okay, and then you would have to cross multiply. If you put those in parentheses and distribute, 6 to the 3 is 18, and then 6 to the positive x is plus 6x is going to equal 3 times the 12, which is 36, plus 3 times the x, which is 3x. From here, you're going to solve now, okay, and you should be getting, this ends up being 3x equals 18. Divide both sides by 3, you should be getting x equals 6. And now we're going to use our 6 to actually answer the question and find ED. So we are going to use this right triangle right here. Hopefully use pencil so you could erase. I'm now going to erase this because it's going to be 6 plus 3 because it's 3 plus x. So our x was 6. So this becomes 9 now. And from here, you're finding the missing side of a right triangle. So what I will be checking is to make sure that you can solve this. It's going to be, we're going to use Pythagorean theorem, a squared plus b squared equals c squared. Okay, you could substitute 3 in for a and solve for b. And so I will be checking to make sure that you could solve this. So if I were grading this, and I am, you will be getting 1 point for marking up the picture, 1 point for showing and redrawing the similar triangles, 1 point for setting up the proportion, okay, 1 point for getting the x, and 1 point for getting the correct answer. Okay, so hopefully you could at least get 4 out of the 5 points for this problem, but I think you should definitely be able to solve for the missing side length. Oops, and I should put a little squared right there. Okay? Alright, moving on to 32. Okay? So 32, you have a circle. The figure shows circle P and an inscribed isosceles triangle ABC. So that means the triangle is in the circle. Okay? So if segment AC has the same length as the radius of the circle. Okay? So shout out to Mr. Rankin, he also helped with this problem. So our first step was, hey, let's draw a radius. Okay? So we drew in from P to A and from P to C. Okay? So we drew segment PA and segment PC. And then we used that, hey, they told us that segment AC is congruent to the radiuses. So then now we have triangle PAC is equilateral. Okay? Which means all the angles in there, so all the interior angles are 60 degrees. Okay? So if the question says, what is the measure of angle ABC, which that happens to be an inscribed angle, which means the angle is half the arc, okay, we need to find the arc. Lucky for us, we have a central angle right there, which that central angle is the same as the arc. So the arc that we need is 60 degrees, but the angle that we need needs to be half that arc. So you need to take half of 60, and hopefully you can put your answer right in the box. That will be 1 point if you can get half of 60. You'll also get a point for recognizing that triangle or angle ABC is inscribed, and you'll get a point for diagramming your picture. Okay? Alright, your last one, 30. I think this one is pretty self-explanatory. Hopefully you'll be able to do it. Circle T is shown. Line PS and line RS are tangent to circle T. Okay, so the first thing you need to do is find the measure of angle PTR. So PTR is right here, so you should be able to recognize that that is a central angle, okay? Central angle, which means it equals the arc, okay? And when you have two tangents, you want to think about a kite, because remember, that's 90 degrees, 90 degrees. So that's P, T, R. S is 44 up there. And, oops, I hope you guys don't think that's 94. If you're following along, you should know it's 44 though. Okay, so we have 44 degrees, and we need to find that missing angle. So if you find that missing angle, you found angle PTR. So I'm trusting that you could find angle PTR. So I will be giving you a point for drawing a kite, point for getting angle PTR. Okay, and then the last question wants the measure of angle PQR. So PQR is going to be an inscribed angle. Okay, so inscribed angle, which means it's half the arc. Okay, so if you find the central angle, you find the arc that you need. Okay, so again, if you find this central angle, you found the arc that you need to find the inscribed angle. So you would have to take half of that arc. So I will give you a point for that. Okay, so there were only 3 questions for your park practice for this unit. So now you need to turn these in to the red bin or to me, and then check in to see which homeworks you need to make up.